Hi, I am Ioannis and I will be presenting a work called Data Augmentation for Aware Machine Learning. AI systems can amplify biases as explained in this cycle. For example, system outputs influence end user decisions. End user goes for biased option, biased actions become training data, and the system learns to mimic biased behavior. We know that AI models that aim to detect abnormal activities tend to be biased. This stems from the quality of the data they are trained on. In this work, we developed a method that generates synthetic samples, augmenting an existing dataset, thus reducing the bias in methods aimed at anomaly detection in surveillance video. The dataset that we use for our experiment is called RWF2000, which contains 2000 video clips lasting 5 seconds each. During our dataset analysis, we manually annotated the dataset for the races and the gender of the people depicted, and we observed that dark-skinned individuals and males were overrepresented. In our approach, we use an instant segmentation method, mask_CNN, to obtain the bounding boxes and the mask of the individual person in a frame. We use HRNet for pose estimation, and we track the person that we want to replace throughout the video sequence, person 1. In each frame, we resize the replacement person, person 2, in accordance with the bounding box of the original person. We use the affine transformation matrix used to resize person 2 to transform his mask and his joint's location. By subtracting the key points of person 2 from the key points of person 1, we obtain the displacement vectors. We interpolate with the radial basis function and generate the displacement fields for x and y pixels. We warp person 2 and replace him in the original video frame instead of person 1. We will next show an example of our proposed methodology. Having person 2 and also having person 1, we resize person 2, we actually rescale him to match the bounding box coordinates of person 1. We then calculate the displacement vectors and the displacement fields as depicted here for x and y pixels. We will now show a complete example of a person replacement. In the top left image, we have a video frame. In the next image, we have person 2 with his key points. In the next image, we have the person that we tracked throughout the video, person 1, with his corresponding key points. And next to that, we have the transformed key points and the mask of person 2. Using those displacement fields, we generate the synthetic new image of person 2, and we replace that image into the original video frame. We will now present results using our methodology. We generate 20 synthetic video clips that were good enough, 10 of them violent and 10 of them non-violent. We used two 5-fold cross-validation schemes using the RTFM method. One had the original video clips and the other one had the original plus the synthetic ones. To conclude, we observed an increase in accuracy across all 3 test datasets. The AUC score increased in 1 out of the 3 datasets, while it had marginal decrease in the other 2. Judging from these results, we believe our proposed methodology looks promising. To further extend this work, we are considering the use of generative adversarial networks for motion transfer. The research project Darlene has received funding from the European Union Horizon 2020 Research and Innovation Programme. Thank you all for your attention, and goodbye.